Good day, everyone. Welcome to Chemistry with Professor John. This is General Chemistry 1, and we'll continue from the last video on chemical equations. Remember, we have type of reactions. Okay, so there's 7, 8, 9 different type of reactions like decomposition, combinations, single replacements, so on and so forth. Now this is not type of reaction, this is type of equations. So for every reaction, you can write up to 3 types of equations. Some you cannot, of course. For this particular one, for example, the precipitation reactions, when you have a product is a solid. This one, if we just write a regular equation with all the molecules, with all the formulas, we call that a molecular equations. So K2SO4 react with barium nitrate, give us potassium nitrate plus barium sulfate, and that's the precipitate. The solubility rule, the set of rules will help us to determine which compound is a solid. And this one, barium sulfate is a solid. Okay. Now, and this is the solubility rule that we talked about last time. Okay. Now, so, and that's the balance equations. Now, you break them into complete ionic equations. Remember, only break the aqueous compound into ions. All right? Only break aqueous compound into ion, not solid, liquid, or gas. Okay, so we got 2. So instead of write K2, we write 2K plus, sulfate, 2K plus, sulfate, 2 minus, barium sulfate, and 2 nitrate instead of nitrate, parentheses 2. And then similarly on the other side. And then if you notice, we can cancel out potassium, we can cancel out nitrate. So all we have left is just barium and sulfate. That's called a net ionic equation. Okay, so there's a few here for you to try. Notice the equation's already balanced. That's good. So we got 2. So that's the molecular equation. Okay, now let's break into ions, right? Net complete ionic equations. That would be 2K plus C2O4 2 minus, and they all aqueous, plus barium 2 plus 2OH minus, and that's give us 2K plus 2OH minus plus barium oxalate. We leave that alone because it's a solid. So that's complete ionic. And then after we cancel out, potassium cancel out, and hydroxide. Yep. So we end up with barium plus oxalate give us there. This is going to be the net ionic. All right. Over here, make sure we don't break that. Okay? Make sure we keep that. Well, this one we keep 2. So actually this one, we don't need ionic equation because really there's nothing we can break, only sulfuric acid. Okay, so this one, try to think. Okay, so only molecular equations. Okay. All right. Now, acid-base reaction, that's neutralization reactions, and your product always going to be water plus a salt. Okay, that's a salt. Water and salt. Oxidation reductions, that's when an element is oxidized by losing electron, and then the other element will be reduced by gaining electron. Okay, for example, magnesium react with oxygens, give us magnesium oxide. So magnesium from neutral, which is 0, to become 2 plus. And oxygen from neutral become 2 minus. That's reductions. Okay. So our job is to be able to identify what type of reaction here. This would be combinations. That would be the best way. We can also call it redox or redox. This should be that's a base, that's an acid, so this is acid base or neutralization. This with oxygens, I think the best is combustions. And this one, that's pretty tough. It's either redox or there's a single elements there, carbon, so single replacement or redox. This is obviously decomposition, and this one is acid base again. That's a acid, that's a base, so neutralizations. And then this one has a solid product, so we call it precipitation. All right. Okay, chemical calculation. Now this is a good one. Remember, whenever we do chemical calculations, we need balance equations, and we also need molar mass to convert gram to mole, and later we convert mole to gram. All right. So, for example, we need mass of sodium azide. That's sodium azide. That's already balanced equations. We got volume of nitrogen gas, and so we have 73.6 liter at 1.25 gram per liter. So that will give us gram of nitrogen gas, which is N2. So that's why we need molar mass. From the gram of nitrogen gas, we can convert it to mole of nitrogens, and then we can do the ratio for 3 nitrogen to 3 mole of nitrogen for every 2 mole of sodium azide, which is NaN3. And then we go from there. So with that, moles of nitrogen gas, oops, I had it backward. So it should be it should be 2 mole of NaN3 for every 3 mole of nitrogen gas. So that way we can cancel nitrogens and we get the moles of NaN3, and if you get the molar mass, you can convert it to gram. Okay. All right. We'll get the rest of them in the next video. Well, thank you, everyone.